Section 3.5 is on implicit differentiation. So we're going to learn the difference between implicit and explicit functions, how to use implicit differentiation, and then this is going to help us with logarithmic differentiation. So it says implicit and explicit functions. Up to this point in the text, most of the functions have been expressed in explicit form. For example, in the equation y equals 3x squared minus 5, the variable y is explicitly written as a function of x. Some functions, however, are only implied by an equation. For instance, the function y equals 1 over x is defined implicitly by the equation xy equals 1. So when you solve for y, that is called explicit form, and if you have both variables on one side of the equation, that's called implicit form. So all they did was multiply both sides by x to get this. So this is called implicit form. It says to find dy dx for this equation, when it's in implicit form, you can write y as explicitly as a function of x. So again, you would divide both sides by x, and then that's really x to the negative 1, right? And then you could find the derivative. So the derivative of y with respect to x would be negative 1 over x squared. It says this strategy works whenever you can solve for the function explicitly. You cannot, however, use this procedure when you are unable to solve for y as a function of x. For instance, how would you find dy dx for the equation x squared minus y cubed plus 4y plus 2? So you might think, okay, let's isolate y. So you would subtract x squared from both sides, and then you would say, okay, how do I solve for y? You could factor out a y, but you would still have y's on both sides of the equations. It just wouldn't work. You can't solve for y. It says, for this equation, it is difficult to express y as a function of x explicitly. So to find dy dx, you can use implicit differentiation. What should you think of implicit differentiation as? Think of it like the chain rule. If I said, what's the derivative of u squared? You would say 2u to the first, or 2u times u prime. We're going to do the exact same thing, except we're doing it with y's now. So the derivative of y squared would be 2y times y prime. Now they call it dy dx, and you're trying to solve for dy dx. I personally call it y prime. So this messes with a lot of students, but the idea is, what if I said find the derivative of y? Well, you would say, okay, well, what is y? Well, I want you to imagine y as a horrible, horrible, horrible function, like I've written right here. This nasty, nasty function. And if someone ever says find dy dx or find y prime, I simply want you to say it's y prime. That's what it is, okay? So instead of finding the derivative of it, what you're going to think implicitly, you're thinking that y is a nasty function of x, and so you're just going to say the derivative of it's just y prime, okay? So that's what it says. It says if someone asks what the derivative of y squared is, you would just use the chain rule and say it's 2y times y prime, or 2y times dy dx. Again, I'm going to be using this 2y y prime. That's what I prefer to use. Instead of writing dy dx, I like the prime notation, but it's the exact same thing.